Hi everyone, in this video I'm going to take you through a statistical analysis of two maps I have for a lake, for a Sarangan lake in East Java, Indonesia, and one showing the depth cluster and that we made before, that I made it before and then uploaded in the last video in my YouTube channel. And the next maps showing the temperature cluster, and these maps represents different zones within the lake classified based on the depth and the temperature. So they have similar cluster. They have three clusters. For the depth zones, they are shallow, medium, and deep. And for temperature, we have low, medium, and high. So this video is to compare the relationships between these two variables using several statistical approach. Yeah, but specifically I will be looking at the Pearson's correlations, ANOVA Test, K-means clustering, T-square, linear regressions, and GLM, Generalized Linear Modeling. But this video will be only focusing on the Pearson's correlations. Well, the Pearson's correlations here is a statistical test that measures the strengths of the linear relationships between two variables. In this case, we are looking at how the depth zones and the temperatures zones within the lake relate to each other. Yeah. So the Pearson's correlations coefficient range from -1, 0, and +1. -1 indicates a perfect negative correlations. 0 means there is no linear correlations, and +1 mean that there is a perfect positive correlations. Yeah, in the simpler terms, maybe positive correlations mean that as one variable increase, the other tends to also increase. And the negative correlations mean also one variable increase. When one variable increase, then the other decrease or will decrease, like that. And a correlation close to 0 means there's like no significant linear relationships between two variables. So here step by step breakdown of the code. The first step is to match the data sets for depth and temperature based on their spatial coordinates. Yeah, in this case, the x and y value here, this represent the latitudes and longitudes coordinates of each point in the lake, and we need to combine these data sets so that we can analyze the depth and the temperature data in the same data, yeah, in the same variable on the same locations. Here, yeah, this one depth zone df is my depth data sets, which contain information about the depth zones, and temperature zones, yeah, it contains the data sets about the temperature itself. Yeah, by merging them on the coordinates x and y, we ensure that we are comparing depth and temperature for the exact same spatial points. Yeah, here. And the next code here, this is how we calculate the percent correlations between the depth zones for the layer x here and the temperature, which is the layer y. And here's what the correlation function is doing. Like for the x represent the depth zones for our combined data, and the y is for the temperature zones. Yeah, we use method of Pearson here. Okay, now we can run this, and here we get the correlation results. We get yeah, the results tell us that the Pearson's correlation between the depth and temperature zones is 0.04 to 98092. This is very low positive number, and yeah, which means that the relationship between the depth and temperature zone is like extremely weak in Sarangan Lake, and almost like non existent in terms of yeah linear correlations. I think they still have, but just little correlations. Yeah. Okay, now the next we can visualize also the scatter plot. Yeah, in this data we use ggplot2 here to create a scatter plot that is showing how this works. So the IS contain X and Y layer. This maps the depth zones to the x-axis and temperature zone to y-axis. Yeah, like I said before. And the home point, yeah, this plot is point on the scatter plot where the depth and the temperature zone intersects. And Helmholtz method with the color blue. This adds a linear trend line to the plot and showing the general directions of the relationships between the depth and temperature zones. And yeah, here finally we have the it's still loading to get the plot of the Pearson's. Yeah, this one. Yeah, it show like 0.0429 correlations. When the scatter plot, you see that the points are widely scattered with no clear upward and downward trends. So yeah, the line of the best width is almost flat, which visually confirms that there is little to no linear relationships between the depth and temperature zones in these datasets. And yeah, even though we have a weak positive correlation of 0.043, it's not statistically meaningful in this case. Okay, so yeah, the Pearson's correlations results shows that there is almost no linear relationships between the depth zones and temperature zone in the Lake Sarangan, East Java, Indonesia, and yeah, that's all I think. Yeah, for the next video, I will also make how make to I will make a video about ANOVA means sculpturing T-square and linear regressions and GLM as well. Yeah, but for today this concludes our analysis on the Pearson's correlations, and thanks for watching. Bye.